Section 2 in Chapter 7 talks about earthquakes releasing energy. We talked yesterday and the day before about earthquakes themselves being just releases of energy that's built up when rocks and those plates get stuck. They're trying to move and they're trying to move, but they can't. They get stuck, and then eventually they break free, and that breaking free releases all that energy. Well, earthquakes, when they do release that energy, they let out, or they give off that energy in the form of waves. Not waves like in the ocean, but waves of energy. Well, maybe like waves in the ocean too, because they're energy as well. But these energy waves travel out in all directions. They travel up, they travel down, they travel from diagonally side to side. These seismic waves, and that's what they're called. They're called seismic waves from earthquakes. They're vibrations in the ground caused by this earthquake. Now, there are a couple things that you have to know, a couple vocabulary words. One is called the focus of an earthquake. Now, the thing that you have to remember is that the focus is the point underground where the earthquake originates, where the rock first moves. Focus is underground. These seismic waves travel out from that focus. Now, there's another term called the epicenter right here. The epicenter is the point right on the surface of the earth where the earthquake, right above the focus. So if you can kind of see my picture over here, you have the focus, and then you have the epicenter right above it, right on the surface. Well, like I said before, all these energy waves travel out from the center of the focus, and as they move, they actually, it's kind of weird that they move the particles out of position just temporarily, and allows the energy wave to keep on traveling through. Now, an earthquake, the three seismic waves that it does make, something called a primary wave, and they label this one the P wave, and then this one the secondary wave, the S wave, and then the surface wave, I think they just call that the surface wave itself. Now, the fastest of all those waves is that primary wave. They're the ones that travel through most of the material. They get there first. Wherever the seismic station that's reading it, they're the ones that get there first. They are the fastest ones. The secondary waves, just like it says, they're the second one to get there to the measuring station, the seismic station that's measuring the seismic waves. Seismic waves can travel through rock, but they can't travel through liquids or gases. Primary waves, unlike primary waves, they cannot travel through liquids and gases. Okay, surface waves. Well, those surface waves, those are the waves that travel along the surface, obviously, because that's the name of it. They don't travel through the inside of the earth. Now, the surface waves, these are the guys that do a lot of damage because they're the ones that are causing the ground to move up and down and side to side. Seismic waves, we can measure these. We can measure these on a thing called a seismograph. Seismograph, that's one of those things that you've seen probably before, where the little arrows on an ink, and it just goes, shakes back and forth and shakes back and forth and shakes back and forth. And the bigger ones, they shake big ones, and then the small ones, they shake small ones. These seismographs make a seismogram, which is the actual drawing of it. Now, when we take those measurements of those waves, those primary waves and the secondary waves, we can figure out actual locations of the epicenter where this earthquake happened by following these steps. One, we have to find the difference between the arrival times of the primary and secondary waves at 3 different places. And we need 3 different places, and I'll show a little video here that will explain why we need 3 different places. The time difference is used to determine the distance. The greater the time difference, the farther away from the epicenter. So the bigger the difference between the primary wave coming and the time that the secondary wave actually gets there, the bigger that difference is, the farther away it is. And then eventually, once we get all 3 measurements, we can draw 3 circles on a map, and where all 3 circles intersect, that's where the epicenter is. Now, in your book on page 233, there's a a page that explains how to find the epicenter. I'm going to show you a video though.
Let's do an example of how to locate the epicenter for an earthquake that takes place in the United States. This is a seismograph from Salt Lake City. Here's where the P wave arrived. It was 1 minute. Here's where the S wave arrived. That was at 4 minutes. So let's write that down. The arrival time for the P wave was 1 minute. The arrival time for the S wave was 4 minutes. So then the difference in arrival time for the P and the S wave is equal to 4 minutes minus 1 minute, which is equal to 3 minutes. Okay, so we know the difference in the arrival time. That's all we need to know to come to the P and the S wave chart here and to find out how far away the epicenter was. So I measure out 3 minutes over here on the scale for time. See that? Now I slide along the P and the S wave chart until I find exactly where 3 minutes fits. Right there, you see that? Now I drop a line straight down that little dotted line, and I found it. I put a little box around it. That's 1,800 kilometers. Therefore, we now know the city is 1,800 kilometers away from the epicenter. So I go to my map right here. Now, if you look right up here at the top of the map, there's a scale, and I'm going to measure out 1,800 kilometers. You see that? It's right there on the scale. Okay, that measures 1,800 kilometers. Now I'm going to take that line, and I'm going to bring it down here to where Salt Lake City is. Okay, just done that. See that line? That's 1,800 kilometers. I've labeled it. Now, if I were to draw a circle around Salt Lake City that's exactly 1,800 kilometers in radius, like I've just done there, then anywhere on that circle we could have had the earthquake. We don't know where, but anywhere on that circle we could have had it. Okay, once again, I measure out 800 kilometers up here on the scale. I measure that same distance from Houston. There's 800 kilometers. I draw the circle, and as you can see, this circle intersects in 2 spots. Now we've narrowed down how many places the earthquake could be to one of these 2 spots. Okay, now remember, when you guys do it, you're not doing it on the computer. You're going to be using a compass, and you're going to measure out the distance with the compass. You put 1 point at 0, you put 1 point at the distance. In this case, it would be 1,300 kilometers. And then you put 1 spot on the city, and you are able to draw your circle. So we measure 1,300 kilometers from Savannah. We draw our circle. And as you can see, all 3 of these circles now intersect in 1 spot. Okay, so I put a box around this spot. Now, you haven't finished until you've actually put an X where the epicenter is. So here's my X, okay, and now I'm finished. I have my 3 circles. They all intersect in a single spot. I've marked that with an X. That's where the epicenter is.
So as you can see, you need to have those 3 locations to find the 1 spot. Now, if you found just 1 location and you saw how big that circle was, it could be anywhere in that circle. When you found 2 distances from 2 different places, you had 2 spots where the earthquake could have happened. Well, we need to have that 1 because if we have resources that we have to send there to help people out, we have 2 places. We'd have to send half the resources to one and half the other, and one of them wouldn't use the resources. So we need to find that 3rd place, to find that 3rd resource, or that 3rd spot, so that we can actually find where all 3 circles intersect, and that's where the earthquake is. That's where we have to send our resources. Now, here are some review questions real quickly. The first question says, why does the greatest shaking of the ground occur near the earthquake's epicenter? Remember, the epicenter is that spot right on the surface of the earth where the earthquake is. No. the answer to that is because, you know, the earthquake started at the focus, which was right under the ground where the epicenter is. So as the energy waves move farther and farther away, they lose their energy. So most of the energy is given right there where it started. What information do you need to completely describe where an earthquake started? We just got done talking about that. We need to know the epicenter, and we need to know how deep the focus was. Um, did it happen closer to the surface? Did it happen farther down? And then where is that epicenter? And we have to figure out that by using those three circles and trying to find where all three circles intersect. And then what types of information can scientists get by studying seismograms? Um, that seismogram is the scribbled ink, and I'll show you some examples tomorrow. But you can figure out where it started, how strong it was, where the primary wave is, and where the secondary wave is. So hopefully you got that down pretty well. Make sure that you get ready for the quiz, and that's it.